To start today's lesson, let's just take a look at real-world data and how it relates to equations, in particular in slope-intercept form. Here's a situation. Your brother has 500 songs on his digital media player. He joins a music club that lets him download 30 songs per month for a monthly fee. The number of songs that he could eventually have in his player, if he does not delete any songs, is represented by y is equal to 30 times x plus 500. So we see that we can calculate the number of songs based on this information. So writing linear equations is our focus in this chapter. We're going to go and talk about slope-intercept form, y is equal to mx plus b. And as we already know, the variable m represents slope, and the b variable represents the y-intercept, which is that point on the y-axis. We're going to first look at these equations, graph them, write them, and use them to convert them to other forms of a line. In my first activity this morning, I'd like to look at an equation or several equations in slope-intercept form, and let's start by just identifying those key pieces of information that make this easy to use in a quick graph form. So let's look at the first one. If y is equal to mx plus b, then m is represented by the number 2 and the y-intercept point on the y-axis by 4. In my second, the number in front of the variable is 1, so my slope is 1, and my y-intercept here is -3. We're just identifying. My slope is just the number or coefficient in front of the variable. In this case, it's -4. Now, my y-intercept is my point, my starting point, and if we think back to work that we did previously, we know that the y-intercept of a model of direct variation passes through the origin, so that means my y-intercept is 0. Old material comes back in other forms. My next one, my slope is a -6. My y-intercept is -5. My slope is a ratio of rise over run, so you'll see it in fraction form as well. We know that when it's a whole number, we place it over 1 in order to graph. And there we have some examples. One last one here. M, which is my slope, is a -6/5, which tells me to go down and over. And my y-intercept, the point on my y-axis, is 2. So knowing these two key pieces of information allow us to do what we call a quick graph method. We've already learned how to graph a linear equation using a table of values, but there are other methods. We're going to do a little review of graphing linear equations in slope-intercept form. If I give you an equation, y is equal to 3/2, 3/2 x minus 4, I start off by identifying my slope, which is 3/2, it's positive, and my y-intercept, which is -4. So we always start by doing these two things. Now, what are we going to do with this? We're going to graph it. So once we have identified, we're going to just do it. I'm going to just do a rough sketch here. We'll do more formal ones on the next slide. If I start with my y-intercept point on the y-axis, it'll be at -4, 0, -4. My slope is a positive 3/2. Tells me to count up 1, 2, 3, 1, 2, 3, and over 1, 2, and there's my second point. We need just 2 points to graph a line, and there is my first graphing using slope-intercept form of a line. Here are my directions, and again, we have done some of this already, so this first section or two will go very smoothly. The graph of an equation in slope-intercept form will start by plotting our y-intercept. It's a point on the y-axis. I like to identify these key pieces of information I many times will ask you to identify your slope, M, and your y-intercept, B. Start plotting that y-intercept. Now, a y-intercept, the point on the y-axis would be 0, 4, which means I start at the origin and I count up 1, 2, 3, 4. It's a point on the y-axis. My slope will give me my second point. Now, slope is constant, so I can put as many points as I want, but we only need 2. So I'm going to start and put my pen back on my y-intercept, and I'm going to count up 3, rising 3, 1, 2, 3, and over 1, 2. Connect the points. You see that we have this positive slope, and 3 over 2 was a positive number. Let's try 1 or 2 more. Identify your slope. Identify your y-intercept. Start plotting with the y-intercept, counting down 1, 2, 3, negative 4. Now we keep our pencil there and we go up 1, 2, 3, and over 2 and connect. Just that simple. Let's do a little practice. Identify your slope. That's how we started off this lesson, by identifying. Why? So that we can start by graphing at our y-intercept 3. My slope this time is negative. It's going to go down and to the right, counting down 1, 2, 3, and over 1, 2, 3, 4. I have 2 points. I have a line. This one is negative, and so is my slope here. It has a negative symbol right here. One more perhaps, going down to negative 2. So my M is 6 over 5. That's telling me to go up 6 and over 5. B is negative 2. So I have my first point. I now count up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, and connect. So we can do a series of these, but I think by now you have a good handle on this. But I want to show you one which is slightly different. This time the equation is given in standard form. So the first thing we need to do is rewrite it. So I'll start by subtracting that 3x to the other side of the equation. Subtracting 3x on the left and the right. So I get 2y is equal to negative 3x plus 6. And then I'll divide everything by 2. Now I have an equation, y is equal to negative 3 over 2x plus 3. Now we can graph it, because now we see we have our slope, and we have our y-intercept. The final thing I want to discuss today is what happens when we have constants. We've already talked about horizontal lines having a slope of 0, so we know that it's going to just go straight across. So they have this form, y is equal to b, where b is any number other than 0. So if I want to graph y is equal to negative 2, I'm going to go down on my graph to the y-intercept at negative 2. And I know that all these values here will also have a y-coordinate of negative 2. And that's how I graph y is equal to negative 2, a constant function. And that's our lesson for today.